You know, our entire world runs on electricity. But have you ever stopped to think about what's actually behind the switch? It's more than just wires. There's this invisible set of rules, a secret language, really, made of numbers that governs every single spark. And today, we're going to make it visible. We are cracking the unseen electrical code.
All right, to get started, let's play a little game. I'm going to show you 4 different numbers, and on the surface, they look like they have nothing to do with each other. But they do. Your job is to try and spot the hidden connection. Ready?
Okay, number 1, 765,000 volts. Whoa, that is a massive, almost astronomical number, right? Just tuck that away for a second.
Next up, 8.4 meters. Okay, so we've just gone from this gigantic electrical force to a length, something you could measure out with a tape measure. How in the world do those two connect?
And number 3, 2 sockets. Now that feels familiar, doesn't it? This is something personal, something you'd find in your own house, maybe your bedroom. So what's it doing in this puzzle?
And for our last clue, 2 millimeters. We've gone from the absolutely massive to the minuscule. I mean, that's like the thickness of a couple of credit cards. So let's recap. We have this immense voltage, a specific height, a number you'd find at home, and a tiny, tiny thickness. What is the common thread here?
The answer is, they're all part of the exact same system. They're all words in the same hidden language that brings power from a plant hundreds of kilometers away, safely right into the wall next to you. Yep, they are all part of the electrical code.
Okay, so let's start cracking this thing open. And, like with any language, if you really want to understand it, you've got to start with the basics, the grammar, the fundamental rules that everything else is built on.
So what is the electrical code? Well, it's not just one book. Think of it as this gigantic library of standards and engineering knowledge. It's the master instruction manual for our entire electrified world, and its whole job is to make sure this incredibly powerful force is tamed, controlled, and actually useful to us.
And here's a perfect example of that grammar in action. These are 2 really fundamental ways to wire up a big system. Now, don't get bogged down in the formulas. That's not the point. The big takeaway here is that everything, and I mean everything, follows these super precise mathematical rules. That square root of 3 you see, that's not a suggestion. It's a fundamental law, like a rule of grammar, that dictates exactly how voltage and current have to behave.
All right, so we've got the grammar down. Now let's start reading the story of electricity's incredible journey. And we're going to start big. I'm talking the largest possible scale, the massive arteries of the national power grid.
And look at that. There's our first number again, 765,000 volts. This table tells you exactly why that number is so important. If you need to move a mind-boggling 3,500 megawatts of power, that's enough for a huge city, over 500 kilometers, the code says this is the most efficient voltage to use. It's an absolutely stunning feat of engineering, all calculated for that perfect balance of power, distance, and cost.
So, obviously, you can't just string a wire carrying that much juice on any old wooden pole you find, right? The code has whole chapters, entire sections, dedicated to the massive physical structures that literally hold our grid together.
Check this out. Every single time a high-voltage line has to make a turn, the code specifies exactly what kind of tower to use. If it's just a tiny bend, maybe up to 2 degrees, you use a Type A tower. But for a really sharp turn, or where the line ends, you got to bring in the big guns, a heavy-duty Type D dead-end tower. See? Absolutely nothing is left to chance.
And hey, remember this number? 8.4 meters. This is where you really see the human side of the code. This is the absolute minimum distance that a 400 kilovolt line has to be from the ground. It's a non-negotiable safety buffer between all that immense power and us, the people walking around down below. You could say it's a rule written in meters, but it's really measured in human lives. Okay, so we've seen the code working on this massive, national scale. Now let's start zooming in. How does that epic power from those giant towers make its way down to your street, and then, finally, into your house?
Well, the whole system is basically one big, carefully orchestrated journey downward. The voltage is stepped down piece by piece. It goes from hundreds of thousands of volts, gets knocked down at a substation, sent along local lines at something like 11,000 volts, until a final transformer near your home brings it down to that familiar, safe 240 volts you use every day. Every single step is controlled, calculated, and dictated by the code.
And that brings us to the final stop, the end of the line. We're zooming in to the most intimate scale of all, the electrical code that's literally running inside the walls of your home right now.
And this is where it all clicks into place. The same huge, complex rulebook that designs those giant transmission towers also has recommendations for how many outlets should be in your bedroom. And would you look at that? This table, right from a National Electrical Code, says you should have 2 standard sockets, our mystery number. It's for things like your lamps, your phone charger. It's just incredible. The code is everywhere, from the power plant all the way to your pillow.
Just stop and think about that journey for a second. We started with the colossal power of 765,000 volts, way up in the sky, managed by giant towers with 8.4-meter safety clearances, and we followed it all the way down to the 2 little sockets recommended for your bedroom, which are housed in a plastic box in your wall with a minimum thickness of just 2 millimeters, our final mystery number. From the monumental to the minuscule,
Every single number, every rule, from the grandest, most epic scale to the tiniest, most precise detail, it's all part of this one single, intricate, and absolutely essential system. It's the invisible architecture of our modern lives.
So maybe the next time you plug in your phone, you'll see it a little differently, not just as a simple socket, but as the final stop on this incredible journey, all of it governed by a hidden language of numbers. It really makes you wonder, doesn't it? Now that you can see this code, what other invisible systems are just waiting for us, hiding in plain sight?